variations are our relationships between our variables. This is what we've been using. However, we haven't really been talking about it in these kinds of terms, but they're just how we describe the relationship within our equations, and how the variables relate to each other. So we have our direct variation, which we know as y equals k times x. And this is our direct variation. So we say y is directly proportional to x. So how much ever x goes up by that k, y goes up. So let me just write this here. K in all of these is a constant of the variation. Okay, so this is variation. This is going to be some number. Okay, so you can see in this number one example, we've got y equals 2x. So we've got a number, a constant, multiplied by x. So this is a direct variation. So these are kind of like our linear equations. They are our linear equations. All right, let's look at inverse variation. Y equals k, our constant, some number, over x. And so what this says is y is inversely proportional to x. So these are the kind of functions and equations that we've been doing lately, our radical and rational equations. So this is like this number 2. One thing I want to note here is that on all of these, even the joint, whenever I get there, you're going to need to make it y equals. They're all going to have y equals on one side. And then you can tell what kind of variation it is, and what your k constant is. So this one already has a y equals. Where's my x? My x is down here. So this one is an example of an inverse variation. All right, let's look at our third one we're going to have, and it's going to be joint. So y equals k, constant, some number, times x, times z. So this time we're going to have 3 variables. And so this says that y varies jointly as x and z. So joint variation is kind of easy to point out because we're going to have all 3 variables, y, x, and z. So that's like number 4 here. So we would want to put this 4 over 3 on the other side, and our fractions are funny when we move them. We flip them. So really this is y equals 3 over 4 times x, z. So this has got our y, x, and z, so we know that this is a joint variation. Okay, so let's go back up here to number 1. So we're not only going to be identifying what kind of variation it is, but I want to know what that constant is. What is k in this example? And so that's just the number in front of our x. So same thing here. What is k? What's our constant? It's the number above x in our inverse. So that is 24. So on our joint, that's the number, k is the number in front of our x and z. So that's 3/4. Let's look at getting this number 3 into y equals and figure out what variation it is. and what our k is. So we need to get y by itself. Right now it's being divided by x, so I'm going to multiply both sides by x. So then y equals 2/5 times x. So what's happening here? X is being multiplied by some constant to give you y. So that is a direct variation. And k is that number, 2/5. All right, well, let's look at some short word problems and write the equations for those. So if y is directly proportional, so we're up here with our direct, so we're going to have this kind of formula, y equals k times x. And then the rest of it tells us what's happening, so we can figure out what k is. So if y is directly proportional to x and y equals 28, so all I'm doing is plugging in what I know when x is 7. So we don't know k, but we know that if x is 7, then y is 28. So I can solve for k by dividing both sides by 7. And k equals 4. Okay, so now I'm going to rewrite my y equals with my k. So now it's y equals 4 times x. And then the rest of that problem says find x when y is 52. So I'm going to plug in 52 for y this time. Now I know my k and I don't know my x. So this time I'm going to get x by itself by dividing both sides by 4. 52 divided by 4 is 13, so x is 13. So here's your steps. You want to identify, maybe I should, let's write this here. Our steps: identify the variation, fill in your variation equation with givens. So it's probably going to be your y and x to solve for k. Rewrite your variation equation with your k. Then plug in and solve for the problem. So let's go through these. Identify your variation. If y varies jointly with x and z, and y equals this when x and z equal these, find y, x, blah, blah, blah. So jointly. So we identified that we have a joint variation. So we're going to have y equals k times x times z. And then fill in your variation equation with what's given. So y is 48 when x is 8 and z is 15, and we don't know k. Next step is to solve for k. So I'm going to divide both sides out by whatever 8 times 15 is. So 48 divided by 120, that is 2/5 equals k. All right, that was step 3, solving for k. Step 4, we're going to rewrite this variation with our k that we just found. Y equals 2/5 xz. Fifth step is plug in the last part of your information and solve for what it's asking for. So it wants us to find y, so we don't know y, equals 2/5 times x is 14 times z is 20. So then I'm going to do the math, and y equals 112. Okay, let's go through this last one. If y is inversely proportional to x and y equals 7.5 when x equals 8, find x when y is 5. So inverse this time, so we're going to have y equals k over x. Let's plug in what we know. We know y equals 7.5 when x is 8. So let's solve for k. Right now k is being divided by 8, so we need to multiply it by 8. And 7.5 times 8 is 60. Rewrite it, y equals 60 over x. Okay, what are we given in the second portion? We want to find x when y is 5. So y equals 5. 5 equals 60 over x. I need to get x by itself. So this one is a little tricky at first. So right now we need to get x by itself, but first we have to multiply x on both sides. So now we have 5x equals 60. X is still not by itself. So we need to we need to divide both sides by 5. And 60 divided by 5 is 12. So we wanted to find x when those, okay. So identify, when you're given a word problem, identify your variation, fill in what you know so you can solve for k, solve for k, and then rewrite it in a y equals statement with your new k value. K is just a number, and then plug in what you are given to find what you need to know.